Hello to everyone, and thank you for watching my video. The asymmetric cryptography works because everyone has got two keys, a public key and a private key. These two keys are tied together mathematically. Your public key, it's public and anyone can know it, and you can show it to everyone because it's also your address. People need it to know where to send you, their bitcoins. Instead, the private key, you must keep it secret 100% all the time, because it's a kind of password that allows you to use your bitcoins. Here below you can see an example of public key and private key. And the best thing of all is that you can create a private key and a public key in like less than 10 seconds in websites, for example, as bitaddress.org. So in 10 seconds you can just create them, and when you've created them, you can automatically, immediately have access to a Bitcoin wallet. And this, I think it's a really important thing, because if you think about banks, to create a bank account you need a lot of time, you need to say a lot of private information. In Bitcoin it's not like this. Also in banks, sometimes you must even pay money. In Bitcoin, it's just free. So, how does it work, a Bitcoin transaction? A Bitcoin transaction is when you send Bitcoins from one public key, so from one address, from one wallet, to another public key. For the transactions to be valid, you must sign it. To sign one transactions, you have to create a signature using your private key. And then miners, that are the ones that have to validate the transaction, just by seeing your signature and your public key, can know that you used your private key without seeing it. And this is really important, because if you think about it, banks know your password. When you sign a transaction, you put in your password and they compare it. Okay, yes, it's the same. It's him. But instead, in Bitcoin, it's trustless. No one must never know your private key. Using this system, Satoshi Nakamoto allowed miners to validate the transaction, so they can know that you used your private key, but without seeing it. An example that quite helped me to understand asymmetric cryptography is by comparing it with Coca-Cola. What do I mean? Well, everyone knows your public key in Bitcoin, but also in Coca-Cola, everyone knows its ingredients. With the Coca-Cola, when you drink it, you can taste it, you can see, and the Coca-Cola, you can understand it's Coca-Cola. But even you can taste it, you can see the ingredients, you cannot understand what is the secret recipe. With Bitcoin, it's quite similar. Even if everyone knows your public key and everyone can see your signature, it's impossible to find your private key. Let's put an example of a transaction. Imagine that I wouldn't put I, but I would put my public key, want to send one Bitcoin, that is the amount, the quantity, to Bob. Obviously I wouldn't put Bob, but I would put his public key. For the transaction to be valid, I would have to sign it. I would have to create a signature using my private key. Here below you can see an example of signature. And just by seeing this message, miners can know that I send a message, because they can, as I said before, by seeing my signature and my public key, to understand that they had my password, my private key. They can also see that the message wasn't modified through some calculus, and also they can know that I have the Bitcoin that I want to send. How do they do this? Well, they go to the blockchain and look for all the transactions that contain this public key. When they have found all of them, they calculate them, they calculate the balance, and if I've got one Bitcoin or more, they allow the transaction. So we can say that the moment of transaction will be validated.